Hi, my name is Aniket. I am a research engineer at Lightning AI, and I'm going to talk about serving GenAI workloads at scale with LitServe. Before going through the presentation, just in case if you guys don't know about Lightning AI and what we do, PyTorch Lightning has 28K stars and it has more than 150 million downloads. Some of the work which has been created using PyTorch Lightning are Tiny Llama, Stability AI. If you know about the text to image generation model from Stability AI, it was trained using PyTorch Lightning. And it's also used in industry by, for example, NVIDIA Nemo has been trained using Lightning. Fun fact, it's also being deployed on billions of systems worldwide with Microsoft. So RWKV.cpp is a recurrent neural network based large language model which has been trained using Lightning and is now deployed on billions of systems since it's shipped with Windows 11. Some of our open source projects are PyTorch Lightning, Torch Metrics, LitGPT, which is for LLM training and fine tuning, LitServe, which I'm going to talk about. It's a model serving framework. LitData, it's a very fast, scalable, and optimized data set optimization library. And Lightning Thunder, which is a like deep learning compiler project. Talking about Gen AI models, like we mostly deal with text generation, image in painting, and audio generation. Like there are some other types as well, but usually we like these days at least we mostly do text generation. Everyone wants to serve LLMs at very fast speed, and the issues which comes with serving LLMs are high computational costs because of the huge size of the model. We need very large GPU memory for fitting the model, and latency issues. These models are quite like slow to like process and generate the tokens. Some of the bottlenecks are the reason we face these issues are because of global interpreter lock in Python. So if you are using a Python based server, we face the issue called global interpreter lock, which kind of slows down the whole system. And single thread in Python has like a lot of performance limitation. This leads to inefficient resource utilization. So we are going to talk about some tips and tricks which kind of like LitServe provides you some optimized way to get rid of all these things. So latency and throughput is can be improved and is dependent on like the model size and complexity. So you can like quantize the model to improve the latency and throughput. You can do things like continuous batching to process more requests together and like so you fully utilize the GPU resource. You can also stream responses early. That means, for example, if you want to generate something from an LLM, you don't need to generate the whole sequence first and return to the client. You can stream the tokens as soon as it's generated. So you send token by token. For example, when you chat GPT, you don't wait 1 minute to generate the whole sentence. It's streamed to you, word by word. So LitServe is a project. It's in pure Python and it's completely open source. So you can just go to GitHub and to install it, you can do pip install LitServe. It's a model serving framework and it's based on top of FastAPI. We have done a lot of optimization internally, which makes you like you don't have to do a lot of kind of management of like GIL and other like Python based issues. You won't have to deal with all those things. So you can just use LitServe, implement a model inside LitServe, and it will make sure that your model is scaled. Some of the key points of LitServe is it's pure Python. It's framework agnostic, which means you can serve models from PyTorch, TensorFlow, JAX, or even scikit-learn. You can serve any model, be it a large language model, an image generation model, like even an image classification model. It's battle tested. We have like done a lot of testing about its performance and correctness. Like we have very strict test on our like for every PR we do a lot of test for to make sure we don't break anything and our performance is always on par with all the other frameworks. For example, Tosser, it's secure, so you can we have put a lot of inbuilt functionality to make sure it's secure, like you can secure your APIs with authentication tokens, OAuth and stuff. And finally, it's open source and community driven, so you can just install it, like clone it, and if you think like there could be something with improved, you can just create a PR and we will work with you to merge that and fix the issues. Let's say provide automatic dynamic batching, so you don't have to implement anything. For example, if you want to set a dynamic batch size of 4, you just set an argument batch size and it will be done for you. You can do auto scaling, you can serve LLMs. It supports streaming out of the box, so you don't have to implement anything. It has OpenAI compatibility. You can serve a local model, a Llama or DeepSeek, and expose an OpenAI compatible endpoint and with minimal amount of cooling. So I will show you some demo. This is a simple example to show you how to convert a regular machine learning API from FastAPI to LitServe. So this is a very vanilla example. Like, it has defined FastAPI. It's loading a scikit-learn model here, and it has defined a predict function where you take the features like the input request and just return the response. So there are some issues with this particular approach. First of all, there's no dynamic batching. If you are running it in a single thread, you might get issues with GIL. Um, and yeah, so to scale this model, so API, we can convert it just with simple changes to lit server. So here I have imported from LitServe in import LitServe as ls. I've defined a class which inherits from lit API, ls.lit API. You need to define these 4 methods: setup, decode request, predict, and encode response. Which is like, if you think about it, setup is where you define your model. Decode request is where you take the input from your client and decode the request. Then the returned object will be flown to predict method, where you do the inference, and the returned object will again be flowed into encode response. So it's like a pipeline. Like, it first goes to decode request, predict, and encode response, and finally it will be returned to the client. Now to scale it, you can set like max batch size is equal to 4, 8, whatever like your system can sustain. You can also have this argument worker per device, so you can have multiple processes running your model in parallel. And there are some other functionality, some other arguments as well. Like, you can check the documentation. We have like documented all the arguments in depth. Lot of these APIs has to be deployed, and to deploy these APIs, you need to make Docker container. So we have made it simple by creating a simple CLI, which is let's serve dockerize your script name like server.py here, and it will generate a Docker image automatically for you. So if you want a GPU Docker image, you can just specify a flag $-GPU. It will generate the Docker image. And we are also going to connect this to our Lightning AI cloud platform. So Lightning AI has a platform where you can deploy all these kind of models. It supports auto scaling. It has a serverless environment as well, so you don't pay when you are not using the server. To do that, you can just run some commands. We are still kind of working on it, but it's going to launch soon, so you can just run, like, for example, lightning deploy server.py, and it will deploy your server on cloud. You don't need to do any like cloud-based configuration like AWS or GCP. And the good thing is, like, you can connect your GCP cluster or AWS cluster with lightning. Here is the example of serving a llama 8 billion parameter model with LitServe. So on the left side, you see server.py. So that's the amount of code you need to create an OpenAI compliant server on, like, for any local system, like any local open source model. For example, in the setup method here, we define the model and we just need to do predict. The only difference here is, instead of returning the response, we use the keyword yield. So in Python, the yield keyword is used to return like a, not return like just return like send the response for that particular like as much currently we have generated. So it will generate the token and send it to the client part by part. And on the bottom we have a OpenAI compliant client which basically send the request to the server. So it's super like convenient to like serve any model with LitServe, serve any LLM with LitServe. For security, you can add authentication as well. So for that, all you need is you just set a like API key in your LitServe server, and it will make sure that whenever any client makes a call, they have to provide the same secret key in the client as well. Otherwise, it will give them an authentication error. As a conclusion, I'd say LitServe is super optimized for serving any kind of model. It's framework agnostic. It's open source, completely free to use. So I would suggest like just check out the documentation. We have a lot of examples. Like go through the examples, check if you have a similar use case, and you can just try the example, change the model to what you need, and tune your parameters. Like we have in detail documentation about how to scale and how to speed up your server as well. So yeah, that's all from my side. Thank you so much. And this is the QR code if you want to like connect with me on LinkedIn or Twitter. You can scan this QR code and reach out to me. Thank you.